And then we'll solve these questions. So there's a question number 182. It says BRICS company is seeking to establish a relationship between money spent on a dedicated customer care department and the feedback scores achieved as part of customer service, and has decided to use linear regression with the following results. So this is the question. This is the formula. I just pasted here. So it says X is equal to spends in thousands of dollars and Y is equal to score achieved, measured between -10 and +10. So the variables are given as sigma X is given, sigma Y is given, sigma X square, sigma XY, and N is equal to 12. So if the regression line of Y in relation to X has to be given, see the equation Y is equal to A plus BX. So now in that case, Y is equal to A plus BX. So we need to know what are the variables A and B. Okay. So B is calculated in this manner, N into sigma XY. We have sigma XY as 14,200. N is the number of items 12. Then sigma X is given, sigma Y is also given. Then after that, we need to multiply N sigma X square. Sigma X square is there and sigma X is there, sigma X whole square. So just have to substitute the values in the equation. B is equal to this. So I already pasted the formula here. See, typing it here is not such a simple task. So I just cut and pasted this formula here. So let's just substitute the values to find out what is B. So this is question number 182. So for that, we need to know what is first B is equal to. So B is equal to, we'll put the numerator first. So N is 12, 12 into 12 into sigma XY is 14,200. Then after that, we have minus. It's the product of sigma X and sigma Y. Sigma X is 560. So 560 into 85. This is the numerator part. After that, we can write the denominator here in the next row. So if this is the numerator, and the denominator would go like this. In the denominator, we have N is 12. 12 into X square is 62,500. Then minus, we have sigma X whole square, that is 560 whole to the power of 2. Okay, let's use the calculation here. Are you with me? So if you can also do along with me, that would be great.
I'm doing it in Excel as well.
That's perfectly fine. So now let's find out, after B is calculated, we need to find out what is A. A is equal to sigma Y minus B this is y bar minus b x bar. So now a is equal to, we need to know what is y bar. Y bar would be, bar is basically the average. So y bar is the average. So sigma y. So whatever is sigma y, which is 85, 85 divided by 12. So that will give us y bar. Then minus b. Already we know b value. X bar. X bar is sigma x by n. So um, we can substitute these values. A is equal to, if it is y bar can be written as 85 divided by 12. That is y bar. Then minus, we know what is b. B is 0 0.281, 0 0.281. Then into, it is x bar. X bar would be sigma x. Sigma x is 560. 560 divided by 12. So let's find out what's the value of A. Now regression line is y is equal to a regression line of y on x is equal to. So the equation is given as y is equal to a. A we already calculated. We already calculated b also. Bx. Okay. Now what's x? X is not given. The answers are also given in the equation form. If the value of x is given, we substitute x value also and then find out what's the value of y. But we are not asked to calculate what's the value of y. We are just asked to frame the regression line. So regression line would be y is equal to a. We got it as minus 6.03, 6.03 plus b value we have it as 0.281 x. Okay, that's the equation. So on that note, it should be B. B is the answer. Now let's see question number 183. A company uses regression analysis to establish its selling overhead cost for budgeting purposes. The data used for the analysis is as follows. See, the gradient of the regression line is 4,200, which is x. Gradient is x. Using regression analysis, what would be the budgeted sales overhead cost for the month in thousands of dollars if there are 2 salesmen employed? Okay. So here we see that the number of salesmen, different number of salesmen during different months, and the overhead cost is also given to us. Now, if there are 2 salesmen, what would be the budgeted sales overhead cost? So that is what we have to calculate. So now the equation we have it as y is equal to a plus bx, but we need to know what are the values of a, what are the values of b. So that is what we need to first find out. X value is already given. Okay, x value is equal to 4,200. Now A has to be known and B also has to be known. So if we look into from this equation, A is equal to y bar minus B x bar. Now what is B? So if we need to find out, B is the number of salesmen during a particular month, if it is 2, and the gradient of the regression line, which is 4200, that is the cost which is given. Now in that case, we need to find out what is y is equal to. B is equal to, it says 2 salesmen employed. Now what is all what we do not know? We do not know what is A. See, y is equal to A plus B x. So we know B x, but we do not know A. So on that note, A is equal to, just now we have looked into, A is equal to, the equation goes like this. So in the sigma y bar minus B sigma x bar. There are two variables given. One is the number of salesmen, one is the sales overhead. Okay, there are two things which are given to us. Um, so we need to know what are the we write it here, or I was looking at shall we write it here? So we know sigma x is equal to, I will write it here. Um, Total of y is equal to 183,000. Then we have n is equal to, what is n? N is equal to the number of items which are there, which are uh, throughout 5 months. So n is equal to 5 items. So we would have it as 5. Then we also have the total of x. Symbols are not, so I'm just writing the full form. Total of x, we have it as 21. Okay, so we can see it here, the formula part of it. A is equal to sigma y minus B sigma x. So sigma y is equal to sigma total of y by n. X bar is equal to total of x by n. So on that note, if we take it here, we just paste it this side so that for our reference sake it will be there. Okay. We now have A is equal to sigma y minus B sigma x. Sigma y will be sum total of y divided by n number of items. So in that case, here it will be 183,000 divided by 5, close this bracket, minus B. So B is equal to 2. B is equal to 2 into sigma x by n. So sigma x by n. B is 2. X bar is equal to sigma x by n. So sigma x we have it as 21. 21 divided by 5. So A is equal to I don't know. I guess I made a mistake. I made a mistake here. Just let's look into that. The equation is y is equal to a plus bx. B represents the gradient. I just wrote it as x. I am really sorry about that. So B represents the gradient or the slope of the line. So on that note, let me correct it here. This is not x. This is B is equal to. Okay. B is equal to, instead of 2, it is 4,100. So now the equation would look like this. R14, A is equal to this minus this would be, in place of 14, it should become 15. Okay. If there are two salesmen, number of salesmen is x. So x is equal to 2. Y is equal to a plus b x. So a or b already got. We have the value of a, which is 18,960, plus the value of b. B is 4,200 into the salesman is 2. So y is equal to so the answer is 27,360. Question number 184. An organization is using linear regression analysis to establish an equation that shows a relationship between advertising expenditure and sales revenue. It will then use the equation to predict sales revenue for given levels of advertising expenditure. Data for the last 5 periods are given as follows. We have 5 periods, then advertising expenditure is given, and then sales revenue is also given. What are the values of sigma x, sigma y, and n that needs to be inserted into the appropriate formula? We need to calculate, add them up. I will write it here so that we can easily do the calculation. 184 question number. So for 184, we have a period number. It is 1, 2, 3, 4, 5. And then we have advertising expenditure. And then we have sales revenue. The figures are 17,000, 19,000. Okay. So this is variable x, and this one is variable y. So if we are asked total of x is 100,000, total of y is 600,000, n is 5 items. So if it is total of x, it should be 100, total of y should be 600, and n is equal to 5. So B is the option. Question number 185. Over a period of 10 months, a factory monthly production cost range from 5 to 16, while output in units ranges from 50 to 500. If the regression equation is y is equal to 5.0913 plus 0.2119x, which three of the following statements are correct? Okay. When we have an equation, I am writing it here. There is an equation y is equal to a plus bx. See, generally, now this is used to establish the relationship between the dependent variable on independent variable. But then this equation is also used to find out the relationship between costs, because the question, there are certain variables given. There is already a regression equation which is framed and given, and the answers which are given are all focusing on fixed cost and variable cost. So regression line y is equal to a plus bx can also be established to find out the proportion of variable cost and fixed cost in the total cost. See, there are, based on the behavior of the cost, costs are classified as variable cost, fixed cost, or semi-variable cost. Semi-variable cost is partly fixed and partly variable. If it is partly fixed and partly variable, so this equation establishes the relationship between that portion which is variable that and the other portion which is fixed. See, in this equation, there are two constants, A and B. X is a variable. X is an independent variable. Then we see A and B are two constants. So if this particular equation, if we look into two parts, okay, there is one constant which is A, which is not connected to any other variable. Okay. Then we see another variable B. B, the second part of the equation keeps changing as the value of X changes. B is a constant, but the second part of the equation Bx, that value keeps changing with the changes in the value of X. Okay. Y is equal to A plus Bx. Now that's the equation what we have. A is absolutely a constant, so it doesn't get affected because of change in anything. So here, out of the cost broadly classified as variable cost and fixed cost, we can um, take A to be as the fixed cost and B to be as the variable cost per unit. See, the relationship of cost, fixed cost is a cost which remains fixed. See, when we look at the graphical presentation also, see, there is a cost which remains, the total fixed cost remains same right from zero number of units till the maximum capacity. So it doesn't change. So the total amount of fixed cost is a constant. So in this part of it, A can be taken as total fixed cost. Then we see variable cost varies proportionately with the increase in the output. So that is what we see. Why? See, the per unit variable cost also is constant. Let's say if the variable cost per unit is $5. So at zero number of units, what's variable cost? It is zero. Zero into 5 is zero. At 1 unit, 1 into 5 is 5. 2 units, 2 into 5 is 10. 100 units, 100 into 5 is 500. So it changes proportionately. It changes proportionately with the changes in output. Proportionately, why are we calling it? Because the variable cost per unit remains the same, it doesn't change. Therefore, the total amount of variable cost varies proportionately with the output. That is the point here. So y is equal to A plus bx, in which A is a constant, B is a constant, and with the changes in x, the value of y also changes. So in that case, A can be taken as total fixed cost, B can be taken as variable cost per unit, and x is the independent variable. So if that is the situation, there is already an equation which is framed and given to us. So I'm erasing the screen. The equation is if we are to talk about what can these variables represent, where we see A is equal to total fixed cost, B is equal to variable cost per unit, X is equal to independent variable. Independent variable could be, it could be depending on number of units, it could be number of labor hours, number of machine hours, or some whatever is the measurement of that particular activity. So X is equal to independent variable. Examples are number of units, number of labor hours, number of machine hours, etc. So that is how it would be taken into consideration. So we do not know much details. We only know that there is an equation given. A is equal to 5.0913 and then B is equal to 0.2119x. The first paragraph, it talks about over a period of 10 months, the factory's monthly production cost ranges from 5 to 16, while output X ranges from 50 to 500. So in that case, we need to select any three of the following statements. So when X increases by 1, Y increases by 0.2119. Then fixed costs are 5.0913. Then when X is equal to 0, Y is equal to 5.11249. Then fixed costs are 5.09. It is a repetition, no? B and C 091. Okay. Maybe this is a mistake here. Okay, two decimals are there. Then fixed costs are 211.9. Variable costs are 211 2111.9 per unit. Variable cost is 5.0913. So out of this, what do you think is correct? You just figure it out.
Yes. So
This is
D is correct. Fixed costs are 5,000.
now we'll go point by point. Can A be correct? So
A
that
is correct. Yeah, when X increases by,
see,
yeah,
this one is
A is correct.
constant. This one is also
Yeah,
constant. When X changes by 1 into this particular value. Okay. So this will not change. So Y will increase by 0.2119.
0.2. Yeah.
Okay. So on that note, A can be correct. B. Fixed costs are 5.0913. Okay. So fixed costs are 5.0913 is correct. Um, the same thing is presented here and
Yeah,
here
A
as well.
and D also. Yeah.
The point is maybe they are looking at, maybe there is a this decimal is not here. The reason is, see the number of units, the um, over a period of 10 months, the monthly production cost Y, that is in thousands of dollars. So thousands of dollars is, it is multiplied into thousands of dollars. So the three zeros have to be added here. So maybe the decimal um, have to move, because when three zeros are added, decimal from here will move till here. 1, 2, 3. Zeros are there. I think by mistake this decimal was put here. So it is a mistake. So from here it has moved to three places to the right side because it is thousands of dollars. So the total fixed costs are 5,000. This is a comma, 5,091.3. So D is correct on that note. Okay. If we apply the same logic of thousands of dollars, the same is the logic which will be applied for variable cost as well. So from here, it will move to three digits here. So 211.9x. So variable cost also is this one. So here actually there are two decimals given. Maybe it is a typo. It is not a dot, but it is rather a comma. This is a comma. On that one, D is correct. Question number 186. If the regression equation in thousands of dollars leading sales y is equal y to advertising expenditure x is given by y is equal to 4,000 plus 12x, what is the forecast sales when 15,000 is spent on advertising? See, x is advertising, and if x is equal to 150,000, what is the value of the sales? Sales y is equal to, find out. Just substitute that 4,000 plus 12 into 150,000.
Ma'am, I think we have to put the bracket also. 4,000 bracket something plus bracket.
No need. Mod mass, no?
Yeah.
12 into 150,000. No need actually. It takes the value, so
It's coming to 58 lakhs actually.
okay. Okay. Point is, see, they are again in thousands of dollars. So when sales forecast, when 150,000, so instead of taking 150, we truncate these 3 zeros. Check that. So y is equal to 5,800. See, the point here is in thousands of dollars. So when forecast sales, when the expenditure is given as 150,000, so 3 zeros should be cancelled off. We'll just substitute 150. Because in 4,000 also 3 zeros are eliminated. So here also we should be eliminating 3 zeros. $187. Having analyzed the data from 1,000 customer loyalty cards, FPLC believes it has found a link between how much is typically spent annually on average of product X variable and how much is spent on product Y by the same customer Y variable. The correlation coefficient for 1,000 pairs of X and Y values with X ranging from $500 to $700 is calculated to be 0.79, and the regression equation is y is equal to 620 plus 4.3x. Which two of the following statements are correct? So x is equal to this, y is equal to, x is equal to 550, x is equal to 0. Like multiple level when x increases by 1, y increases by 0.7. 79% of the differences, 79% of differences in money spent on product Y can be explained by looking at the difference in this spent money. So let's first write what are the details that are provided to us. 187 question number. The details that are provided to us are R is equal to 0.79. Then Y is equal to 620 plus 4.3x. Okay. The range, the correlation coefficient for 1,000 pairs of X and Y values with the X ranging from 500 to 700. So then the R value calculated, R is the correlation coefficient, which is 0.79. So it indicates, because 0.79 is closer to 1. So it indicates that there exists a relationship, and in a sense it is quite strong also. So in that case, we have this the y and x are related because 0.79, 0.8, 0.8 is close to 1. So there is a strong relationship. Now in this situation, we do not know what are This is all what information we have. So the options that are given, if we have to look into that, see what is x is, if x is equal to 600, what is the value of y? We do not know. So what we have to do is test out each one of them, then work out. So if x is equal to 600, then let's write what is y is equal to. Y is equal to, we would have it as 620 plus 4.3 into 600. Now x is equal to 600. Whether it is correct or not, we have to verify that. Is equal to 620 plus 4.3 into 600. Yes, this is correct. So next, let's check the other one also. If x is equal to 550, then y is equal to, we would have it as 620 plus in bracket 4.3 into 550. Equal to 620 plus in bracket 4.3 into 550. Okay, so B says that if when x is equal to 550, the estimate of y from regression equation is likely to be reliable. What does it mean, likely to be reliable? So the calculated value is y is okay. So it says that it is reliable, but now we have to justify why is it reliable. Um, the range is given as, the range is between 500 to 700. So if x falls between this range of 500 to 700, I will also write it here. So the information, additional information what we have is range of x is equal to from $500 to $700. So we have selected a value of x between 500 to 700, which is 550. So if it is 550, whatever is the calculated value, that calculated value is reliable because it is applicable to a range ranging between 500 and 700. Therefore, it is reliable. So that we can, but let's also look at the other ones. Then we can come back to that and then talk about it. When x is equal to 0, the estimate of y from the regression equation is likely to be reliable. Range is starting from 500 to 700. 0 is far away from 500. It is not a part of the equation. It is not part of the range. The range is from 500 to 700. So x is not part of the range. So it is, we cannot say that it is reliable. See, this data, this equation, regression equation y is equal to something x is applicable for a range of values of x ranging from 500 to 700. So on that note, C cannot be selected. Then D says when x increases by y should increase by 4.3. Isn't it? Because the slope of x is given as 4.3 because 620 anyway is constant. So for every one value of x increasing, the value of y will increase by 4.3. It is not 0.79. R is 0.79. R indicates whether the relationship between x and y is strong or not. We see that R is equal to 0.79. It is indeed strong. But if the value of x increases by 1, because A is constant, whatever is the value of B, by that number of times the value of y increases. So it should increase by 4.3, not 0.79. He says 79% of the differences in money spent on product Y can be explained by looking at the difference in the spent on product X. So nothing about that. See, 0.79 or 79% only indicates about what um, how strong is the association between variables x and y. So 79% indicates that 79% is not about the difference in money spent on product y and can be explained by looking at the difference in the spent on x. So that is not the case. So here we can go with answer A. A anyway, the calculated value is correct. B, the calculated value is 2985. Of course, they have not asked us to calculate what is the estimated value, but they want to define that the regression equation is likely to be reliable. Why is it likely to be reliable? Because it falls, the value of x falls within the range of 500 to 700. So I will write it here. As x falls within the range of 500 to 700. Okay, so let's take it that way. Then C cannot be the case because x is 0, which is not between the range of 500 to 700. When x increases by 1, y should increase by 4.3, not 0.79. 79% is the percentage of the strong bond between y and x. So it is not E. So we have the correct answers as A and B. A188 says that if there is a perfect positive correlation between two variables, then the value of R, the correlation coefficient is, see the range is, the value of R ranges between -1 to +1. See, it is not about greater than 1. So R falls anything between -1 and +1. So +1 is positive correlation, wherein increase in one variable will result in the increase in the other variable. -1 indicates that when one variable is increasing, we see that the other variable decreases. So that is a negative correlation. But if the value is 0, there is no correlation. Okay. So perfectly perfectly the greater than 1 is not the situation. If it is equal to 1, it is perfect positive correlation. Closer to 1, anything, if it is anything between 0 and 1, as it is closer to 1, it is strong positive correlation. But it goes away from 1 and comes to 0, it weakens. So it indicates that there is no relation. -1 indicates that it is perfect. It is not positive correlation, it is negative correlation. That is, one variable increases, the other variable decreases. So here answer would be, so for 188, I will write it as answer would be B. (189) The correlation coefficient R for measuring the connection between two variables x and y has been calculated as 0.6. How much of the variation in the dependent variable y is explained by the variation in the independent variable x? So yes, there is a relationship, but relationship doesn't indicate that there is a strong relationship. Okay. the question is talking about the explained by the variation. So variance is the what percentage chances are there that it would be away from the average value. That is the variation. So now we need to find out what is the variation percentage. So that is, I am taking you to PPT because we have learned about a variable. We have learned about a concept called as coefficient of determination. The coefficient of determination is given by R square. So what does it talk about basically? See, it explains, it gives the percentage of variations in Y, which can be explained by Y, the corresponding variations in X. If at all, if we have to find out the percentage variation in the variables, then R square is what we have to calculate. See, the question has already calculated value of R is provided to us. So it is question 189, and we have R is equal to 0.6. The question is asking us how much of the variation in the dependent variable Y is explained by the variations in the independent variable X. So now we need to find out coefficient of determination. Coefficient of determination is equal to R into R square. No, I'll just write R into R. So let's calculate what is R into R. Okay, once we calculate what is R into R is 0.6. It's equal to 0.6 into 0.6, which is equal to okay 0.36 or this if we take the percentage, it is 36%. So 189 is 36%. The coefficient of determination R square explains the percentage variation, the coefficient of correlation. So what's the correct answer? Percentage variation, the dependent variable, which is explained.
Percentage.
So B will be the answer.
B
I will
will
use here 190.
Yeah.
Here answer is B. Okay. Then we it is not about independent percentage variation. Independent variable is independent. It is not dependent on the other variable. So it is independent. It doesn't get affected. But the dependent variable does get affected by the changes in the independent variable. Therefore, B is the right answer, not C. Okay, 191. We have CPLC is looking to understand buying behavior for two of its main customers, X and Y. The following table shows the ranking of 6 of CPLC's products by two major customers. So the ranking is already done. So we have the products A to F, and customers are customer X and customer Y is a rank now we need to find out what is rank correlation. So the formula of rank correlation, this is the formula of rank correlation. Let me just copy that and then bring it here. I paste it here. Okay, that's the formula. Okay, where did it go? We want it here. The products. Products are from A, B, to left. Then rank 1. See, I will write it as rank 1, or just write customer X. Customer X rank is given, then also customer Y's rank is given. Okay. Ranks are 4, 5, 2, 1, 3, and 6. Y is equal to 2, 3, 1, 4, 5, 6. So we need to know what is the deviation. The deviation is the difference in the ranks. So D is equal to, we need to find out what is D. D is equal to the difference in the ranks. So rank 1 minus rank 2. I mean rank of the first customer minus rank of the second customer. But if at all, if there is any negative thing, that has to be eliminated. So D into D square basically. So if you are to find out D square, just okay, D square is equal to D to the power of 2 is equal to. So just substitute what is rank correlation. R is equal to, we have 1 minus, see the 1 minus, there is entire fraction given. So here in the numerator we have 6 into 22. Then divided by, the denominator has n is the number of items are 6, isn't it? There are 6 products, so we have the number of items as 6. So take 6. We have 6 into again 6 square. So 6 to the power of 2 minus 1. So let's just do the calculation. We want R is equal to 1 minus, the numerator has 6 into 22. that's the numerator, then divided by the denominator as 6 into in the bracket 6 into 6 minus 1. So rank correlation is equal to 0.37. So yes, we do have 0.37. So this is the answer. (192) says BPLC is trying to assess the extent to which its customers perceive its more expensive products as being better. Towards this, it has asked customers to rank products by quality, and it has then compared this to the ranking by price. If data comprising 10 pairs of corresponding rank has sigma d square is equal to 304.5, where D represents the difference between corresponding ranks. What is Spearman's rank correlation coefficient? Give your answer correct to the two decimals. So sum of D square, I will write it. 192 question number. Sum of D square. I'm just writing the word is equal to 304.5. Then we have N. N is the number of items. N is equal to 10. So now we need to find out what is R. R is equal to, I'm just the way we have written here, I'll just 6 into for us D square is 304.5. 304.5. For us, N is not 6, N is 10. Okay. Answer to two decimal places. So what kind of a relationship it indicates? It is minus. If it is minus, it indicates that there is a negative correlation. It is a strong negative correlation because it is very close to -1. So it indicates that as the variable, uh, if one variable is increasing, we see that the other variable is decreasing. But that's why it is a negative correlation. So it indicates that there is strong negative correlation. (193) PLC is assessing the impact of advertising on customer perceived quality of its products. If the rank correlation coefficient between variable X and variable y is 0.85. Which two of the following statements are correct? 0.85. The rank correlation. Values of y increase as values of x increase. Okay, y decreases by 0.15. It is a we can see that it is a positive correlation. If it is a positive correlation, if one variable is increasing, we can see that the other variable is also increasing. So that is the point what we have to remember. So if values of y increase, when the values of x increase, so that is an indication that it is a positive correlation. And since the r value is plus 0.85, so we can see that one variable increases, the other variable also increases. So a can be correct. Why b cannot be correct? Because y decreases. It is not about decreasing, but it is about increasing. So in that case, b, no matter what it is, cannot be selected. It is not about decreasing. If it was decreasing, if one variable, independent variable is increasing, if uh, if it is a negative value, then the dependent variable will decrease. But it is a plus 0.85. Therefore, b cannot be the answer. Y increases by 0.85 for every increase of 1 in x. See, we cannot state that. See, if the regression equation was given as y is equal to a plus bx, for every value of x increasing by one unit, the value of y will increase by the value of b. Okay. 8.85 is to indicate what kind of a relationship exists between the variables, whether it's strong or strong positive or strong negative, or what is the kind of relationship. It is not the gradient or the slope of x that it will change by 0.85. So on that note, C also cannot be selected. See, if it was y is equal to a plus bx, for every one value of x increasing, value of y will increase by b value. 0.85 is r value, not b value. Therefore, it is not the correct answer. D says the link between x and y values is very strong. Yes, it is strong. Why? Because it is closer to plus 1. Therefore, it is strong. Then the link between x and y values is linear. If it was linear, see, if it was a linear thing, then it would have been in a straight line. Straight line linear relationship is defined as y is equal to a plus bx. But the relationship y is equal to a plus bx is not defined. We only know the rank correlation, the difference in the ranks between two variables, and then it is calculated. It is not in the form of y is equal to a plus bx. If it is the case, it would be linear, it would be in a straight line format. That is not there. So D is correct, not E. And what about F? The increase in X cause corresponding increase in Y. Okay, increases in X cause corresponding increases in Y. That we X is a independent variable. So independent variable cannot increase because of an increase in y. That would be wrong. Rather, it would be a. Y is a dependent variable. Dependent variable changes whenever the independent variable changes. Values of y increase as values of x increase. Okay. A can be correct, and then D also can be correct because the relationship is a strong relationship. I will write the answer here. 193 is A and D. One 194 says, okay, come to this chapter. This is The question says that unemployment numbers have got in a term. So there is a multiplicative model for seasonal adjustment. We didn't discuss the theoretical aspect. Okay, maybe we will extend. I don't know whether we will be able to finish it in the remaining half an hour's time. If we can finish, fine. Otherwise, tomorrow for 10 minutes we can meet one more time. The last chapter in the paper, informational context of business 3, it is about forecasting. See, when the data is analyzed, data is used, the analysis is used to predict the future or forecast the future. So first part of it, we have looked at what is the meaning of data. Data which is collected is to be processed, that is, it has to be arranged in rows and columns, or it has to be um, categorized or classified, put it under headings, and then fit them into certain classes or groups, or group them into clusters, etc. After that, if whether there is any relationship between the variables or not also has to be tested. That can be done with the help of correlation coefficient. R indicates what is the relationship which exists between the two variables that are selected. So if the values, R values lie between -1 and +1. So if they are close to +1, it indicates there is a strong relationship. If it is close to -1, it indicates a strong negative correlation. If it is closer to 0 or 0 or closer to 0, it indicates that there is 0, there is no relationship. Closer to 0, the relationship is very weak. Okay, that's one part of analysis. Another part of analysis is what is the data, what is the trend of the data also has to be understood. Okay, so for that we have variables like time series analysis, then finding the trend, moving averages, seasonal adjustments. So basically, we would understand what is the nature of the data, what is the trend of the data. So time series analysis basis. So if a time period is selected and the variables are studied over a period of time, in that case, what is the trend of the data can be understood. Here it says that there are considered to be 4 components in time series. First one is the trend, the seasonal component, the cyclical component, and the residual component. So what is the trend? The trend talks about the general overall movement of the variable without any sharp fluctuations. So if the data is studied over a period of time, if it is studied, how is the data moving ahead? What is the direction? Whether it is going upwards, whether it is coming downwards. So some pattern would be there. So instead of, without taking any sharp fluctuations, the general pattern. See, if the data points are all um, plotted on the graph. See, let's say that the data points are somewhere like this. One point is somewhere here, another point is somewhere here. Then we see here. But overall, we can understand that there is a pattern here. There is a pattern which is upward rising. So instead of connecting them like this, sharp fluctuations, see, instead of doing that, it is there is a trend line which is fitted, which would be covering most of the data points, and then look at. But basically, when we understand what are the what's the trend of the data points, we can see that that is moving upwards. So that's how the trend of the data is generally understood. Right, the general overall movement of the variable without any sharp fluctuation. Then, what is the seasonal component? See, um, all through the time period, we may not find some of the variables to be constantly the same. There may be fluctuations on account of season. Some of the products are seasonal products, some of the businesses are seasonal businesses. In such situation, we see that the variables change during those seasons. So seasonal impact, seasonal component is. Then we see the cyclical component. Cyclical component reflects what are the trade cycles in an economy. Because of we see that inflation, stagflation, recovery, boom. See, during those periods also the data would definitely vary according to the trade cycles of the economy. So that is given, that is the component given by C. The last one is residual component. Residual component R is a variation caused by random fluctuations and unpredictable or freak events. So there is no particular reason, but there would still be some fluctuation. It could be because of change in the minds of the customers, see their expectations, etc. So multiple reasons could be there for the fluctuation. So that is R. So in case of predicting the future or forecasting the future, we have two models. One is an additive model and one is a multiplicative model. So additive model, y is equal to the sum total of all these four components, that is the trend, the seasonal component S, the cyclical component C, and the residual component R. Multiplicative model, y is equal to, it is the product of all the four components. Okay. The R is inherently unknowable. It is residual. It is random. It is not any particular reason for that. It could be just like the sometimes we see that there could be a fluctuation. R is inherently unknowable and so is generally omitted. For annual data, we would omit S. Okay, S is seasonal component. One full year if it is considered. In between, during a particular year, in between the year, if there are any fluctuations on account of seasonal aspect, see that can be omitted if the annual data is considered. So overall, on an average for one full year is the data which is considered. So for annual data, we would omit S and R and work with the models. Y is equal to T. T is the trend and C is the cyclical component, or Y is equal to T into C. For daily, weekly, monthly or quarterly data, we would omit C and R and use models. So C is the cyclical component because they are looking at only a short period of time. During that short period of time, the cyclical movements are not very significant there. So C, we would omit C and R. R is the residual component. So in case of a short period of time, say daily, weekly, monthly, quarterly, y would be T plus S or y is equal to T into S. Okay. Y represents the actual value or the forecast value for prediction is being made. Trend forecast for both models. The first step is to forecast the trend. Trend is applicable in both the models where annual data is taken or short periods like daily, weekly, monthly, quarterly data are taken. In both the situations, trend is important, T is important. For both models, the first step is to forecast the trend. So regression equation, substitute the appropriate time into the regression equation. The resulting value of T is the forecast trend. Then overall forecast depends on the model, multiplicative model. Trend into S is seasonal forecast. Okay. Overall forecast trend is equal to trend forecast into seasonal component. Let's move ahead and then look at the calculations. Moving averages also while we do the question, I will talk about average is calculated, but average is calculated based on a time period. As they move forward, the by one year, one period, the average also is calculated accordingly and it is moved forward. I will, as we do the question, I will talk about how to calculate the moving average. Then the seasonal components are calculated by the model. Model Y is equal to T into S. Additive model is T plus S. Then with an example question, we can look into that and then try to understand. So let's take it up, the questions from the Excel file, the exam questions, and then try to understand. unemployment numbers actually recorded in a town for a second quarter of 2015 were 2200. The underlying trend at this point was 2000 people and the seasonal factor is 0.97. Okay. Trend is 2000, seasonal factor is 0.97. Using the multiplicative model for seasonal adjustment, the seasonally adjusted figure for the quarter in which is which of the following? We have to use the multiplicative model for seasonal adjustment. Multiplicative model for seasonal adjustment. See, the seasonal adjustments, we need to know what is trend. Trend into the seasonal adjustments, T into S. That is the multiplicative model. T into S is the multiplicative model. Y is equal to T into S. So we need to know the what are we asked to actually calculate using the multiplicative model for seasonal adjustment, the seasonally adjusted figure for the quarter. So what's the seasonally adjusted factor is what we are asked to find out. See what data is provided to us. The unemployment numbers actually recorded in a town for the second quarter were 2200. So we have 2200 given. Active number of unemployment is equal to 2200 during the period. The underlying trend of is equal to 2000. After that, the seasonal factor for the trend is 0.97. So the question says that use the multiplicative model for seasonal adjustment. The seasonally adjusted figure for the quarter is what? Either the actual data is 2200, the trend data is 2000. When the trend data is 2000, and for that trend, the seasonal factor is 0.97. So adjusted according to actual. That's the logic. So it is a simple cross multiplication. So when it was 2000, so the seasonal factor is 0.97. So we need to adjust the seasonal trend. After that, we need to find out the multiplicate using the multiplicative model. We need to find out. So now, if it is 2200, Y is equal to T into S. S is 0. 2200 by 2000. Then using the multiplicative model. The underlying trend at this point was 2000 people. Trend. Trend. using the multiplicative model for the seasonal adjustment. Seasonal factor is 0.97. The seasonally adjusted figure in whole number for the quarter. What are we to find out? Okay. Kavya, I promise you I'll wind it up. But somehow I got stuck. I'm unable to proceed further for that question. I'm not clear with what that question says. So we have how many? 4 here, and then 6 here. So 10 questions are there. So we'll do these 10 questions tomorrow. I somehow got stuck. I'm not able to think clearly also. So I'll do these 10 questions tomorrow. Maybe it'll take some half an hour or so. We'll finish it and then we can wind it up. Okay.
Yes, ma'am.
We'll meet tomorrow and then proceed further.
Okay.
Okay. Good day.
Okay, ma'am. Thank you.